All right, 10.3 is on inscribed angles. And an inscribed angle is an angle whose vertex is on the circle. So if you remember before, we talked about central angles. And if I have a center of a circle there, then a central angle is going to be an angle that comes from the center of the circle like that. And then based on whatever the measure of this angle is, that will also tell us the measure of this arc, right? Well, an inscribed angle is a little bit different. An inscribed angle is an angle whose vertex is on the circle. So let's say I draw an angle with a vertex at this point right here. Let's say I draw this angle here. That is an inscribed angle. And that is an inscribed angle precisely because its vertex is on the circle. Now, as with the other things that we've seen in this chapter so far, I could draw any number of inscribed angles in this circle. I could draw literally infinitely many of them. But there are some rules that we actually can learn about inscribed angles that help us, that will tell us a lot about different parts of our circle. In particular, theorem 10.8, which says this: if an angle is inscribed in a circle, okay, basically this is saying if we have an inscribed angle, then its measure is half the measure of its intercepted arc. All right, that's a lot, so we're going to talk through this really quickly. Let's say I have an angle that's it's inscribed right there. And I'm just going to label all of these points here. I'm going to label this point A, I'm going to label this point B, and I'm going to label this point C. So A is the point right here where it's crossing the circle, B is the vertex, and C is this other point where it's crossing the circle. What this theorem 10.8 is saying is that when we have an inscribed angle like we have here, the measure of the angle is going to be half the measure of its intercepted arc. This angle intercepts an arc, and the angle that it intercepts, the arc that it intercepts is this arc right here. Okay, and this arc has a measure, right? We know this, that I can measure arcs as determined by both their length and their measure. The measure would be an angle measure, and the length would be a certain distance, like feet or meters. So this angle, we'll call it angle ABC, is going to be one half, and anytime I take half of something, that's like me multiplying something by 1/2. It's either, if I take half of 4, I can think of it as either multiplying 4 by 1/2 or dividing 4 by 2. Both of those fit the description of taking half of 4. So if I'm taking half of the intercepted arc, then we just need to take 1/2 and multiply it by the measure of arc AC. Okay, so theorem 10.8 says that if an angle is inscribed in a circle, then its measure, the measure of angle ABC, is going to be half the measure of its intercepted arc. And since the measure of this angle's intercepted arc is AC, 1/2 times the measure of AC will be the measure of angle ABC. So that's theorem 10.8. Moving right along, we have a couple more rules to go over. Now, theorem 10.9. If two inscribed angles of a circle, let's stop right there and let's just draw what that says right there. If we have two inscribed angles of a circle that intercept the same arc, okay? So I'm going to draw two angles that intercept this arc right here. I'm going to draw two angles that intercept that arc. Here's one. Okay, and then in red I'm going to draw another. Here is another. There we have two inscribed angles. That red one could be better drawn. Two inscribed angles that intercept the same arc. What we know for sure is that if they intercept the same arc, do you see how they intercept exactly the same arc? Then if the arc is the same, then we can say that these angles are congruent. Okay, so if we wanted to write this out, let's say this is point A, we'll call this point B, we'll call this point C, and we'll call this point D. Because arc AD is the same in both cases, because angle ABD and angle ACD they both intercept arc AD, then we know for sure that angle ABD and angle ACD are congruent. Okay. All right, theorem 10.10 says, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. Here's what this is saying. If we have a triangle that's drawn into a right triangle inscribed in a circle, so I'm going to draw perfectly I'm going to try and draw a right triangle as best I can. Okay, that's pretty good. If we know that this is a right triangle, if a right triangle is inscribed in a circle, then the hypotenuse, this right here, let's call this triangle ABC. Then if triangle ABC is right, then we know that AC is a diameter. And like I said at the beginning of this chapter, a lot of how Euclid discovered geometry was within the context of circles. Euclid basically learned everything that you could about the circle, and then he started just inscribing different shapes into the circle. He'd inscribed triangles, he inscribed quadrilaterals, he inscribed all different types of shapes, and was able to use a lot of rules like this to gather a lot of information about different shapes. We know a lot about triangles because of Euclid inscribing them in circles. So this is actually extremely informative. So this is the first part of it. And then the converse would be if we have an inscribed triangle and one side of it is a diameter. So if we know, for example, that this side is a diameter and it goes through the center, then we can say for certain that this is a right triangle. Okay, so you're going to get some practice. We have some practice here, and this is in your notes, so you can check your notes. What I want you to do is I want you to take some time and I want you to work out each of these, and we're going to just check your understanding, make sure that you're with us and you're in the right place. When you're done with these, I want you to go and check them with me. So while you're doing these in class, I want you to go ahead and do these first before moving on, and then come and get them checked with me before you move on in the video. Okay, so go ahead and do that now. All right, now that you've done these, let's go over a quick description of each of these. So if we use theorem 10.8, which says that the angles will be half the measure of the arc, if we know here that this is 90 degrees because it's a right angle, and this angle is going to be half the measure of this arc, then this arc will be 2 times the measure of this angle. And so if the angle is 90, the arc will be 2 times that, so this arc will be 180. Okay, again, we know the measure of this angle, and it's asking us for the measure of this arc. If we know the measure of this angle is 120, we know that has to be half of the arc. So if the angle, since it's inscribed, is 120, then the arc will be 2 times that, which is 240. You should be noticing a pattern here. If we know the inscribed angle, if we know the inscribed angle, then the measure of the arc that it intercepts will just be 2 times that. Again, this one seems straightforward, but you have to read really closely. This one's asking for the measure of arc ABC. That's this arc here. So how are we going to find this arc if we're only given this angle? Well, we know that a full circle measures 360, and we know that this arc will be 2 times the angle. If this angle, inscribed angle, is 100, then this arc will be 2 times that, which is 200, but that's not the angle that it's asking for, so that's not actually our correct answer. Our correct answer will be 360 minus 200. If a full circle is 360, and we know this is 200, then this ABC, the rest of the circle, will be 360 minus 200, which gives us 160. Man, my mouse is really acting up. 160. Okay. Okay, here, this is a trick question. This is a central angle. So the measure of arc ABC is going to be the same as the measure of the central angle. So the measure of arc ABC is 120. Here it's asking us for the measure of the angle ACD. Now, how can we tell that? Well, as you see, ABD and ACD intercept this arc right here. It's the same arc for both of the angles, and as theorem 10.9 says, I believe it's the theorem 10.9. I'm going to double check that really quickly. Yep, theorem 10.9 says if two inscribed angles intercept the same arc, then those angles are congruent. So if this is 40, then this angle must also be 40 degrees. And then lastly, here we have a triangle. We can see that this side is a diameter because it very clearly goes through the center. So if this is a diameter, that makes this a right triangle. So if we know this angle is 2x, then we know that 2x has to equal 90, and we can find x by dividing both sides by 2. And if we divide both sides by 2, we get that x is 45 degrees. All right, very good. Moving right along, one more theorem really quickly and then a practice problem, and we are done. Theorem 10.11 says this: a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Let's inscribe a quadrilateral into this circle. I'm just going to try and draw something relatively close to a square here. Okay. That's close enough. It doesn't have to be a square, it just has to be a quadrilateral. If we inscribe a quadrilateral into a circle, meaning that all of the angles are on the circle, then this can only be the case if the opposite angles, so here's one angle right here, and here's another, those two angles right there must be supplementary. And that must be true of both cases. So let's call this point A, this one B, this one C, and this one D. We'll call those both points and angles. So this will be both point A, and this angle here will be angle A. As you can see, ABCD is our quadrilateral here. So we refer to quadrilaterals like this, quadrilateral ABCD. This quadrilateral can only be inscribed in this circle if and only if angle A plus the measure of angle A plus the measure of angle C equals 180, and the measure of angle B plus the measure of angle D is 180. Both of those things must be true in order for a quadrilateral to be inscribed in a circle. So on your notes, you will see two practice problems there pertaining to quadrilaterals and circles, and what you need to do is you need to set up the fact that their opposite angles are going to be supplementary. They're going to add to 180. Solve for each of these variables, and when you're done with that, please come and check it with me. Thank you.